Adam Friedman, Vice President at CSD Structural Engineers. In construction engineering, we really look at the building a bit differently. So a typical structural engineer of record is looking at a project or a structure or a system in its permanent state. So when we get involved, we tend to work with general contractors, erectors, fabricators. They have a different perspective in that process. And a big part of construction engineering is looking at these structures in partially completed stages. And so each stage presents a new structure that is different and unique. So some of the challenges that we run into is that we might be missing a load path. So we're missing that system. So in a structure that's all steel, that might use moment connections, they might not be welded at the first step in the process. Or we might have a structure that uses a diaphragm system, which again isn't going to come until later in the process. So stepping through the erection sequence, we're going to start in one corner of the building, and we might have all of our bracing at the opposite end. So how do we use our structural engineering tools to evaluate each step of the process? And some of the things that I've learned along the way is constructability. And that term gets thrown around a lot, and it can mean a lot of different things. One of the biggest things for me, sitting on, in an office behind a computer, is that connection design or that framing on a piece of paper or a computer screen. You don't fully understand what it takes for that to be built in the field. So you've got to put, yourself in the shoes of the iron workers and the tradespeople that are out in the field. Because what looks good on paper, you don't want the phone call that says, we can't get there, we can't access it, it's impossible to do. Taking yourself out of that role of just a designer and understanding how things go together is critically important. So when we think about framing in one respect, and we consider the idea of we're going to take a beam and frame into a column flange or a column web, how can we provide connections as a designer that are easy to access and easy to erect? Because if you can imagine multiple column systems in which we have to drop beams into very tight situations. Remember, you're doing this with a crane. You're doing this with a 10,000 pound piece of steel. You're doing this and it could be breezy out. So all of these conditions create challenges that the iron workers have to overcome in the field. So how can we make that easier? Keep in mind that our time in the office is very inexpensive. The time in the field when a crane is shut down because we can't make a connection work, or we can't get access to something in the field, means that that time is compounded. You've got a crew of iron workers that are sitting and waiting for an answer. You've got a crane that's running, burning gas at incredible rates. So whatever we can do in the office to make that construction more straightforward is critical. But let's make sure we provide details that we know can be accessible. So a big thing is, where does a column splice happen? 4 feet above the floor system. So that allows an iron worker, a welder, to be able to access that weld in a comfortable position. You can imagine that splice being a foot off the deck, and now a welder has to lay down to do that work. Or too high, they've got to work off a shoulder or scaffold. Whatever we can do to make that more straightforward and easier in the field means we're going to get a better welded product out there. When we think about field welding, we got to think about access and how that joint comes together. So if we have to do something field welded, let's give a more reasonable field welded option. Let's use fillet welds that are downhand versus overhead. Let's use partial joint penetration welds whenever we can, because it cuts back on the time needed for inspections in the field. It cuts back on fit up, how that goes together compared to a complete joint penetration weld. Ultimately, if we need to do a CJP weld, we can take care of that. But also understand, especially when we think about a column splice or a truss splice that's welded, we have to be able to hold all of these different elements in place while that weld happens. So we're either incorporating erection aids to hold the upper shaft of a column in place while it gets welded, or using construction equipment. So now our crane is tied up holding an element until we can access it to weld. So again, a decision to use a field welded connection has ramifications in multiple different ways, both for stability and for the time and effort in the field.